Welcome back to my Calculus 1 series. In today's video, we are diving into the fascinating world of antiderivatives. We will explore what they are, why they are important, and how to find them step by step. By the end of this video, you will be ready to tackle basic integration problems with confidence. Let us get started. Now, a function f is an antiderivative of f on an interval I if capital F prime of x is equal to small f of x for all else in I. So let me explain that. So looking at the first question, we have to find the antiderivative of each of the following functions. Now when you are given a question like this, you need to think backward here. You have to ask yourself this question: what function do you know that has a derivative that is equal to the given function? So looking at f of x, we have to find a capital F of x, right? Which function do we know that it has a derivative that is equal to this? So basically, what function do we have to differentiate to get to x? And one thing that comes in mind is if you have s squared. Remember, if we differentiate s squared, you get 2x. So it means that s squared is an antiderivative of 2x. Moving to the b, which function do you think that if we differentiate, we get cosine of x? And that leads back to sine of x. For h of x, which function do we have to differentiate to get the first term right here? Remember, if you have ln of absolute of x, if we differentiate, you have 1 over x, then plus. For the second term, if you have e to the exponent of 2x, if we differentiate this, you end up getting this. So that's the antiderivative of the function. Now, remember, for instance, the first one, having s squared is not the only function whose derivative is 2x. Note that if you have the function, you can have 2x minus 4. Let's say you have this, right? Let's say you have s squared plus 5. Now, if you differentiate this one right here, you're also going to get 2x. You know that, right? Okay. If you also have, say, s squared minus 9, if we differentiate this, you also end up getting this. Okay. So then it means we don't have just one expression satisfying the condition. We have multiple expressions, right? So in this case, what this means is that instead of having f of x is equal to s squared, we can have f of x equal to s squared plus c. This c is any constant, right? So whenever you have s squared plus 5, s squared plus any constant, now you can imagine if you differentiate, you have to get back 2x. So the antiderivative of 2x is s squared plus c. Doing the same thing for this, we are going to have sine of x plus c, because even if you have sine x minus 8, if we differentiate sine x, you get cosine. But if we differentiate this goes to 0. So you have to note. And in doing the same thing for h of x, you just have to add c to make it the antiderivative, the general antiderivative. So let's look at a different example here. So which is example 2. We have to find, the antiderivative of f of x equal to 3s squared that satisfies f of 1 equal to minus 1. Now with this question, what you have to do is, first of all, we want to find our capital F of x. So we have to ask ourselves this question: which function do you think that if we differentiate, we end up getting 3x squared? So we know that if we differentiate x cubed, we're going to get 3x squared, right? But the general antiderivative form, we have to add a c. This question right here basically means that wherever we see x, we have to put in 1. So f of 1 is just 1 cubed plus c, which is just 1 plus c. And f of 1 equal to negative 1 basically means 1 plus c right here is equal to negative 1. So to find c is just minus 1, which is equal to minus 2. So we can substitute it back into this. So we have f of x to be equal to s cubed minus 2. So the antiderivative of this function right here that we want is s cubed minus 2 based on this condition. So if this condition was changed to any other value, say f of 2 equal to negative 1 or whatsoever, we will get a different antiderivative over here, but it will still satisfy this. So just note that. Okay. Let's look at a different one. We have to find the general antiderivative of each of the following. So we have to find the antiderivative of this. We also to find the antiderivative of this, then this, and also this. Okay, so remember, from differentiation, if you are differentiating an exponential function, you would have gotten this, right? So basically, what you do is you multiply e to the negative 3s by the differential, which is negative 3. Now in finding the general antiderivative, instead of you multiplying, what you have to do is to just divide by the differential. So in this case, we have e to the negative 3x, and if we differentiate negative 3x, we have negative 3. So instead of multiplying, we divide, then we add our general form, this. So you can rewrite this as negative 1/3 e to the negative 3x plus c. Okay, so let's move on to the second one. Remember, if we differentiate this, we have 2x ln of 2, right? You multiply by ln of 2. Now, instead of multiplying, we divide. So the antiderivative basically means you have to divide, right? So over here, instead of multiplying by ln of 2, we divide by ln of 2, and we add our constant c. Okay. The next thing over here, for this, if you are differentiating, remember you have 5x to the 4th, right? But now, instead of doing that, we add 1 to the exponent, right? So over here, we just brought the 5 in front, and we subtracted 1 from the exponent. Now we add 1 to the exponent, and we divide by that exponent. And we add our c. So that is your answer. Now, for sine of 2x, when you are differentiating, remember, you first of all differentiate this. 2x, you have 2. Then you differentiate sine, you have cosine of 2x. But now, instead of doing that, what you have to do is the opposite. So first of all, when you integrate, or first of all, let's say if you integrate sine, you get negative cosine of 2x right here. Then you divide by the differential of 2x. So if you differentiate 2x, you're going to have 2. Then you add your constant c. So you just have to ask yourself this question: what function do you have to differentiate to get sine, right? If we differentiate positive cosine of x, you have negative sine of x. So if we differentiate negative cosine of x, then you're going to have positive sine of x. That is why we have negative cosine of 2x right here. I hope that is not confusing at all. So the collection of all antiderivatives of f is called the indefinite integral. So when we combine every antiderivative of f or of a function, that is what we call the indefinite integral. So let's look at this. We have to evaluate the integral of x squared minus 2x plus 5 dx. In solving this question, we can break it into different parts. We can have the first part, which is x squared minus dx. Remember, we can bring the constant outside, so x dx, then plus 5 integral of dx. So as we did over here, remember, whenever you have a polynomial function, what you have to do is to add 1 to the exponent and divide by that number. Then we have our first one, which is c1 minus 2. For the second one, we have the same thing, x squared, then over 2 plus our c2. Then for the third one, we have 5. Then remember, if we differentiate over here, this is 1, right? If we differentiate that, since we are integrating with respect to x, we are going to have x here, then plus c3. So note that we have 3 terms, this and this. So we have s cubed over 3, this negative 2 right here, this 2 cancel this 2, so we just have minus s squared. Then we have this times this, which will just give you positive 5x. And now we have c1 minus c2 plus c3. Now if you combine all the c's together, we just have one big c. So this is the integral of this expression right here. I hope this is clear enough. Let's look at a different question. We have to evaluate 7 sine of theta out of 3 d theta. In this case, remember, you can always bring the constant outside. And if you do that, you are going to end up getting, remember, let me write this one well. First of all, if you differentiate sine, you get negative cosine of the angle you are dealing with. Here we have this. Then you divide by the differential of the angle. Now you have theta over 3. If this is the same as 1 over 3 theta, right? So if you differentiate this, you end up getting 1 out of 3. So in this case, you're going to have 1 out of 3 here. So this is basically, if we write this, you're going to have 7 times 3 multiplying negative cosine of theta out of 3. So 7 by 3 is 21 times negative, so you have negative 21 cosine of theta out of 3. And this will be yours. But remember, this is an indefinite integral, so you have to add your c. Okay. What if you have this? Integral of 4 sec x tan x minus 2 sec squared x dx. So in that case, you have to distribute this. So you bring the constant outside, sec x tan x minus 2 integral of 6 squared x dx. Then you ask yourself, which function do we differentiate to get sec x tan x? And the only function that has a differential of sec x tan x is sec x. And the only differential that will give you secant squared of x is just tangent. Because remember, if you differentiate tan, you get secant squared. Then you add your plus c. That's it. Let's look at the next one. For the next one, we have e to the negative x plus 4 exponent x dx. So we do the same thing where you have e to the negative x dx plus integral of 4 to the x dx. Okay, so ask yourself again, which function do you have to differentiate to get e to the x? The only function is negative e to the power of negative x. Remember, if we differentiate this, we get this function right here. And as we did before, if you want to find the function of this, it's 4x, then divide by ln of 4. Then you add your constant c. Now let's look at the last one. The last one is the integral of cosecant theta cotangent theta over 2 the theta. In this case, we can bring the constant outside, then have cosecant theta cotangent theta the theta. Then you ask yourself, which function do you have to differentiate to get cosecant and cot? Remember, if you differentiate cosecant theta, you end up getting negative cosecant theta cot theta. So basically, it means that if you differentiate negative cosecant theta, you end up getting positive cosecant theta cotangent theta, and that's what we have over here. So using that idea, we can have 1 over 2 multiplying negative cosecant theta. Then we add our constant c. So this is just negative 1 out of 2 cosecant theta plus c. And that is how to solve any antiderivative question. So that is it for today's lesson on antiderivatives. I hope you now have a solid understanding of how to approach and solve these problems. If this video was helpful, don't forget to give it a thumbs up, share it with your classmates, and subscribe to the channel for more math tutorials. Thanks for watching, and I'll see you in the next video. Bye.